algebraic expressions, characteristics and simplifying. So the first thing we have to do is, first of all, do some vocabulary, figure out what these words actually mean. So we're going to start off with the definition for the word equation. Oftentimes students will use equation when they mean expression and expression when they mean equation. So the equation is the symbolic statement that two quantities are equal to each other. Okay, so symbolic statement that two quantities are equal. So the big thing here is, if it's an equation, it has an equal sign. If it is an expression, so up here there's no equal sign. An algebraic expression is just that. It's an expression, such as these examples down here. None of these have equal signs, so those are expressions. Equations have an equal sign. Two things set equal to each other, okay? So one of the things we're going to talk about is how you verify whether an equation is true or not. So just because someone writes two quantities set equal to each other in a statement doesn't necessarily mean it's true. So how do you verify that it's true? So what you do is you find the value for each side of the equal sign. So find the value of the expressions on both sides of the equal sign, and then compare. Okay? So you compare the values on either side of the equal sign. So once you have both sides and you've decided what each side is equal to, then you can compare them and look at them. You're going to have two situations, obviously, right? This is kind of a Captain Obvious thing. They're either going to be equal to each other. So if the values are equal, then the equation is true. And then, of course, if the values are not equal to each other, then the equation is not true. Okay, so that's kind of, once you figured out what each side is equal to, it's kind of a Captain Obvious thing. It's either going to be equal or it's not. Okay, so that's kind of just a quick rundown of the difference between an equation and expression, just to kind of refresh your memory. Other terms you're going to hear me say that you're going to need a little bit of reminder on is what a variable is. So variables are usually letters. They don't have to always be letters. Sometimes they're symbols, but they're usually letters used to represent an unknown value. Okay, usually letters, and they're used to represent an unknown value. I should probably put a semicolon in here to separate the two. A factor is a number or a variable that is being multiplied to another number or variable. So numbers and or variables being multiplied. And we will do some examples of these in a little bit. Okay. A term is an algebraic expression consisting of, this one's kind of long, so if you can write small, you should, consisting of numbers, letters, or the product of numbers and letters. Okay? So numbers, letters, or the product of numbers and letters. Okay, algebraic or terms, algebraic expressions, just as a side note for you, they are usually separated by addition and subtraction. Okay, they're usually separated by addition or subtraction. We'll talk about that here as we move along and start looking at this chart. So you have in front of you a chart that has algebraic expression on the left and number of terms on the right. So we just said that terms are algebraic expressions consisting of numbers and letters or products of numbers and letters. So we are going to scroll the page a little bit. I'm going to scroll the page, and then we're going to go ahead and decide the number of terms in each of these algebraic expressions. Okay, so in this particular algebraic expression, remember I said terms are separated by addition or subtraction. So this is a number and letter being multiplied together. So this is that product of numbers and letters, and then this is just a letter. So in this particular expression, there are two terms. The 3a is a term, and the b is also a term. In the second one, which is somewhat tricky for students sometimes, remember that the definition is that there are numbers and letters being multiplied together, and I'm sure that you would agree that this 3 on the outside of the parentheses means that this 3 is being multiplied by whatever is inside this set of parentheses. So you have to look at this set of parentheses as though it is one item, because we're going to figure out what A and B are, and we're going to add them together and get one value. So it's going to be 3 times whatever this one value is, which is the same thing as saying 3 times whatever x is, right? And this is the product of a number and a letter, and we said that, if you look at 3a up here, they're very similar, was one term. So this 3 times this parenthesis is really just one term. That one's tricky because students see the addition inside the parentheses and try to turn that into more than one term. You have to think about the parenthesis as though it is one thing, because we will boil it down to one value. If you notice in the definition of terms, we talked about numbers, letters, and the products of numbers and letters. We did not talk about division because division does not have an effect on an algebraic expression. Much the same way that whatever's within this set of parentheses is one value, we are going to do the same thing here. We're going to take 3 and we are going to divide it by whatever we get when we add a plus b, and then we're going to do 3 divided by that value, and it's going to give us an answer that is one value. So this entire thing is really just one value, meaning that it is just one term. This would be a value, this would be a value. So that's 2 terms, and we would have to add them together. This is a value, but we're multiplying them. That makes it a term in itself because we're multiplying. Look at this fourth one. We have 1 term, 2 terms, 3 terms. Again, look for those addition and subtraction symbols if that is easier for you to separate them. Just be careful about the ones within the parentheses. So again, here, 1 term, numbers and letters being multiplied together, separated by an addition symbol, and then more numbers and letters being multiplied together, separated by subtraction, and we have the value of b, separated by addition, and then we have the product of a number and whatever is within this set of parentheses when we're finished. So again, that's 1 term all by itself. So in this case, we have 4. And then in this last one, again, think about division as its own sort of term. It's going to give us one sort of value that I then need to add to 1. So there are 2 terms here. Okay, do you understand terms? So separated by addition and subtraction, just go ahead and kind of, if you underline them or circle them, it sometimes makes it a little easier to see them. Okay, so we're going to scroll along and talk about coefficients and also algebraic expressions. So we talked a little bit about that earlier. Coefficients. So a coefficient is a numerical factor of a term. So the numerical factor of a term, we often ask yourself the question, how many do you have? So I'm going to ask that question as we go through this particular chart right here, okay? So when I look at this and I say, oh, we're talking about the variable x, I'm going to ask you, how many x's do you have? And your answer is going to be 2. This 2 is the numerical factor. It tells you how many x's you have, and it's we call that the coefficient. So the number in front telling how many we have is the coefficient. How many ABs do you have? We have -3 ABs. How many n's do you have? This one's tricky because we're dividing. So remember that division can be written as multiplication, right? So if you do 1/3 times n, that's the same thing if you were to multiply it out as n over 3, or n divided by 3. So 1/3 times n is the same thing as n divided by 3. So I could rewrite this if I wanted to say -1/3 times n over 1, or just n. So when I say how many n's do we have, now you can see we have -1/3 n's. So be careful about those division ones. Rewrite them as a multiplication sentence, and your coefficient will appear for you right in the front. Okay, so that's coefficients. So that part of the lesson was just explaining what coefficients were, what algebraic expressions were, and gave us just a little bit of a reminder. The second part is all about writing algebraic expressions, and so before we can do that, we need to focus on what some key words might be. Words that mean the same thing as addition that you might hear in a particular expression. So you're going to get some verbal things written down. You're going to get a big long sentence. It's going to say to do something, and you're going to have to turn those words into an algebraic expression. So when you hear the words sum, you know that means addition. When you hear plus, you know it means addition. When you hear increased by, you hear addition in your head. Wider, if something's wider than something else, you're going to be adding distance, right? If someone's taller, you're adding the height to that thing. Greater is another word that means addition. Expands. There's many, many, many more. These are just a few to kind of give you a hint as you're reading along. Same thing with subtraction. You're going to hear less than to mean subtraction. You're going to hear reduced by. You're going to hear subtracted from. Sometimes they actually use the word. You're going to hear difference. And you might hear less. And you might hear minus. Multiplication, words that mean multiplication. Times, multiplied, product. Okay, division, you're going to hear divided by. You're going to hear how big is each part. I know that sounds really strange, but if we're wanting to know how big each part is, then we're really asking you to divide it to find out what each of those individual parts is, right? So how big is each part might be a way to talk about division. How many parts are there means take what we have and divide it up. So things I want you to focus on here, I want you to think about the sum, that's an important one, the product, the difference, and then the division has a special word that we don't hear very often, dividend, right? And you hear oftentimes the divisor, the dividend, and the quotient. So the quotient is the word that actually means what is the answer to that division problem. Why am I pointing these ones out to you, those four in particular? Well, because when you get ready to write your expression, I want you to think about it like this. I want you to think about writing them so that they are so obnoxiously wordy and you are using as many of those technical terms as you can when you're writing your expression. So sound like a smarty pants and use the really proper terms for them. That's really what we're asking you to do. Instead of saying plus 2, we are looking for you to say the sum of 2 and a number. It just sounds better and it is much more technically correct than to say plus. Okay? So simplifying algebraic expressions, in order to do that, you need to understand what like terms and unlike terms are, because simplifying them means that you're going to gather up all your like terms and make it a simpler statement. So it's not 15 terms long. If you can combine some things and put them together, then you have only something that's a few terms long. That's much more simplified. So just to review, like terms can be numbers, right? Anytime you have numbers, you can certainly combine them. And they can also be variables. But if you are going to be combining variables, you have to remember that they have to have the same letters, and those letters have to have the same exponents. And I'm going to give you a couple of examples. Okay, so that's really important. Unlike terms would be terms that have variables, but there's an issue with those variables, such as different letters or not the same exponents. Okay, that's a problem. And again, I'm going to give you an example of those. So let's go back to like terms. Here's an example of like terms. X squared plus 6x squared. Notice, though, that the coefficient in the front doesn't mean anything. We are really just looking at the x squared. In fact, how many x squareds do you have in this first term? You could certainly say, oh, that's easy, Mrs. Pelletier. I have one term in front of that x squared. And so if I added these together, because I can, these are identical to each other. They're both x's and they're both raised to the second power, then I can combine them and get 7x squared. So those are like terms. Where you have to be careful is where there are multiple, oh, I'm sorry, I need to fix that. There are multiple variables in the expression. Okay, so a squared b c to the third plus 2 a squared b c to the third. So you have to kind of take a second and look very closely. A squared, yes. A squared, yes. I have 1b, I have 1b, and I have a c to the third and a c to the third. So I have both a squared b c to the thirds, and I could then combine them and get 3 a squared b c to the thirds. Okay, so we're combining like terms. Unlike terms, again, it's all about whether they have the same letters or not. So xy plus xz, we cannot combine them. Even though the x's are the same, the problem is that the y's are different. The y is different from the z, and that makes them not like terms. We cannot combine them. Same thing with 3 mn squared plus 4m squared n. Again, while the letters are the same, that's fabulous. The exponents do not match. So we don't have an m squared and an m squared. We can't combine them. Same thing here with the n squared and the n to the first power here. They do not match. Okay, so that's the difference between like and unlike terms and whether or not you can combine them or not.